As we can see, this tractor is being guided along the contour line without the intervention of a human operator. The device drives the tractor by means of a DC motor, which is controlled by a processor that is continually reading the electrical signals of a laser sensor. For a human operator, given their limited reaction time and the lack of precision in their movements, it is impossible to make the tractor stay on the same level. However experienced, in practice they will only be able to mark a path that repeatedly crosses the contour line instead of staying on it. That's where the advantage of a system like this comes from. But how does this device work? When the tractor moves, it changes height, going out of level. By making the sensor move on a vertical guide and stay leveled with the laser beam, the processor measures the change in height of the tractor. Notice that the sensor used in this project only provides the signals up, down or on level with the desired height. But if the photocells sent their information separately as shown in the figure, the height could be read directly, making the movement on the guide unnecessary. Once the difference in height is found, the processor can calculate the horizontal distance between the sensor and the contour line, using the slope of the terrain as the multiplication parameter. Finally, it determines the angle of the front wheels that makes the center of the rear axle, on which the mark in the terrain depends, follow the contour line. To do this, it takes into account that the difference of turn radius between the centers of both axes is the calculated horizontal distance. In short, the operation is based on the fact that the tractor continuously adjusts the curvature of its trajectory to equal that of the curve. Let's see a simple graphic simulation program that mimics the behavior of this device. The goal is that this virtual tractor follow any curve on the screen. That red line on the front axle, acting as a sensor, will continually detect the variable distance between the center of the axle and the curve, and the tractor will rotate based on that distance, just as in the case of the real tractor. Now we make the tractor go, and we see that it does not react until the moment the red line touches the curve. Notice that unlike the human operator, the system does not guide the tractor across the line. Instead, it keeps the center of the front axle, where the sensor is, at a distance that varies depending on the curvature of the contour line. This explains its greater precision, which is corroborated in the tests carried out with the prototype. The results have encouraged us to apply for a patent of invention, and we continue with the development of the project to arrive at a commercial version.